Hello, here is a video about the first lesson of Unit 6, which is about function properties. So the first lesson is about identifying functions and then input-output. This stuff should not be new to you. You've been taught how to identify functions at least 2 times, I think. Algebra 1 in 8th grade, you were taught that. And the function notation input-output, you should have been taught in Algebra 1, but we're doing that today because I need to make sure you can do that stuff before we go on to harder things. All right, so the warm-up is, can you label the coordinates? Can you label the coordinate 3, 2, and all these coordinates? All right, so as a review, I'll do one of them. I'll do C. C is C says 1, negative 5. So the 1 means the x value is 1. The negative 5 means the y value is negative 5. So right here, my cursor, I hope you can see my cursor, is where you'd put a dot for the letter C. Okay, that's how you do that. Write the coordinates labeled on the graph in the table. So that means that there are 1, 2, 3, 4, 5. There are 5 green dots on this graph, and you got to label, like, actually write them. So like, there's a table, right? There's a table. So if I were to do this first one, that would be the first value is negative 2, and the y value is 7. Okay, and that's what that is. Okay, okay. So the reason why that's the warm-up because this is all about y's and x's. This is what functions are about. It's about the relationship between y and x. So a function is a relation or rule that assigns each x value. I can write the x value exactly one, y value. So this should say x value, that should say y value. Each x value is okay. That's x value and then y value. Maybe instead of x value, y value, that should say input. Okay, so instead of the x value, that should say inputs, because input is the way, that's y, that's x, it is, and output is y. Okay, really what input is x, output is y. Okay, so this would be input exactly one, output each x value is paired with one y value. Okay, a graph that is a function will pass the vertical line test. Any vertical lines, so this is vertical and this is also vertical line on the drawn on the graph will pass through only 1 point. So that's 1 point. So this is vertical line test where any vertical line drawn only 1 point. Okay. So to identify if a table is not a function, identify if x is used in more than one coordinate. So like, if x is used in more than one coordinate, it's not a function, okay? If a graph does not pass a vertical line test, I don't need this. Actually, I'm gonna take that out. All right, so then there's these things called arrow diagrams. You actually call it bubble diagrams. On an arrow diagram, if a value of x has more than one arrow coming from it, then the bubble chart is not a function. So, or really the bubble chart. On a bubble chart. Yeah, so what I mean by bubble chart is these things. You see this and there's arrows. Okay, so I'm gonna do these examples. All right, so you can get asked this a variety of ways. You can get asked this with tables, you can ask it with coordinates, you can ask it with graphs. Sometimes the graphs are actual like lines, sometimes they're just points, like this is just points. And sometimes it's these bubble diagrams, meaning like this is a bubble, and there's arrows. I mean, you can call it a bubble diagram, it's also called an arrow chart or arrow diagram, works too. All right, so let's look at A. All right, what I gotta do is identify if I see the value of x being repeated. So the reason why A is not a function is because you see this says -9 and this also says -9. And since their outputs are different, the answer would be no. For number 1, this is no. Okay, this is A, no. For this one, 2, 4, 6, 8, 10, these are all different values of x. It doesn't really matter that the value of y is repeating. Y can repeat, that's okay. X cannot. So that means that is a yes. As for number 2, okay, so this one is a function because it would pass a vertical line test. Like if I draw your vertical line and I kind of move it from left to right, it will only touch one point each time. It touch this 1 point, 1 point, 1 point, 1 point. Okay, so that's a yes. This B is no. The reason why it's no is because you see these 2 points right here, they are vertically aligned. That means if I draw a vertical line or like a pencil and I just move it across like this, that would not work. That would make this not a function. So A is yes, B is no. As for number 3, okay, so if there's only one arrow coming from each value of x, then it's yes. If it's there's more than one, it's no. Okay, so one arrow, one arrow, one arrow, one arrow. All right, now as for, so that's A is yes and B is no. The reason why B is no is because there are 2 arrows come from 25, and that means the value of 25 is being repeated twice. So that's no. So A, yes, B, no. So in review, no, yes, yes, no, yes, no. Okay, so this math is basically the answer yes or no, really. That's all it is. And that's how these work, okay? So bubble chart, kind of like that. Table, this. So we've done stuff like these. All right, so 4 and 5, you're given a list of coordinates, and all that really matters is x. You just got to look at the values of x. If you see x repeat, the answer is no. If x is different each time, the answer is yes. Like number 4, 1, 2, 3, -6, -3. Those are all different numbers. The answer is yes. Okay. 6 is a bubble chart. All right, 7 is a graph. So if you get a graph like this, you put like a vertical line, and you'll notice even though it's not a straight line, the answer is yes. This is a function because on each value of x on this graph, the value of y is different. I mean, the value of x is not repeated. Yeah, the value of x is not repeated. That's what I meant to say. All right, that's, is it a function or not a function? That should look familiar to you. You were taught that in 8th grade in Algebra 1. All right, now let's do function notation. Okay, so this is about identifying if you have a function, and if you have a function, you can make it into function notation. So function notation is another way to express equations, like on coordinates, on a coordinate plane. So, all right, the f, so this is like f of x, this is I say f of x equals 2x. So the f is just the name of a function. It's not always f, like it can be like, I could have wrote g of x equals 2x, that doesn't matter. It could be any letter of the alphabet, honestly. It could be, really. So the f is a name. The x tells you what you input, okay? So if this becomes a number, like if I put in the number 3, that makes this into a 3. Okay, that's what happens. Now if I make this into a 5, this becomes 5. Like that's just what happens. It tells you what the input, like what to put in. And then what it equals is tells you the function. Like the actual function is 2x. Like 2x is the real function. Now this is another way to express y equals 2x. Like you can kind of think of the f of x or the g of x, that like this g is like the letter of the alphabet, parentheses x. Like this is really y. Like this is y. It is. And so like f of x equals 2x is the same thing as y equals 2x. It's the same thing. Okay, so really all the math we're really gonna do for the next, I don't know, 2 weeks has to do with this. Like I'm teaching you a lot of properties about this in the next 2 weeks. We go pretty far into some depth about this. Okay, I feel like I have to before you move on to future math. I kind of have to go into a lot of depth with this. Okay, so the first way you might get asked about this is you're plugging in a number as x and you're actually solving for y. So for example, if f of x 2x plus 1, what is f of 5? All right, that means that, okay, if I have f of x equals 2x plus 1, what this means is I'm replacing the x with 5. Okay, so that where x is gets replaced with 5. So this is now not 2 times x, it's 2 times 5. Notice I'm not writing 25, okay? I don't want to write 25, I want to write 2 times 5, because 2x means 2 times x. And then 10 plus 1 is 11. So like that actually be the answer is 11. And really what this means is that if I make x into 5, y becomes 11. Like that's really what this is. And so that means there's a coordinate on, like when it comes to f of x, 2x plus 1, like, all right, so that coordinate exists on this equation. Like that's really what that does. Okay. Now, as for this, okay, so what you got to be aware of is the letter of the alphabet before the parentheses of x, because the letter of the alphabet tells you what function to use. Like some of these are for questions 8 through 17, if x is 3x minus 2, g of x is x squared minus 3. So if the question says h, like number 8 does, you use the h function. So it says h of 4, so it says 3x minus 2, right? That is h of x. So what that's asking you to do is replace the x with 4. And that means the answer for number 8 is 10. For number 9, it says g. It doesn't say h, it says g. So since it says g, you have to use the g function. So that means, so instead of it being x power 2 minus 3, it's now 8 squared minus 3. So the answer for number 9 is 61. So that's how it works. If it's h, you use 3x minus 2. If it's a g, you use the x squared minus 3. Now, that's not always true. I just made this up. Okay, so like for these specific problems, this is what you do in this one. Okay, now if you're told what a function equals and the number given is the value of y, and you are solving for x. Yeah. Okay, so let's say you're given if h of x is 3x plus 7 and h of x is 25, what is x? So what this is 25 is y. That's one way to look at this. Also, thinking back to when I taught you systems and substitution. All right, if h of x is this, it's 3x plus 7, h of x is that, therefore you can make them equal each other. Like you make 3x plus 7 equal 25, or like that, and you just solve for x. Subtract 7, divide by 3, you get 6. That's kind of how this works. So, for example, all right, we have k of x, 3x minus 5. We have m of x is 5x plus 2. If m of x is 22, what is x? So that means this is 22. So that means 22 equals 5x plus 2. And you would solve for x. That's what number 18 is. Sorry, I got to kind of go fast. These videos can only be 15 minutes. And then it says m of 3. What is m of 3? Well, m of 3 would mean I make the x3 and the answer is 17. So like for this one, the answer is 18. The answer is 4 because you solve for x in this problem. You get 4. For number 19, the answer is 17 because you're plugging in x is 3. So notice like these are really two very different problems, but you're using the same data. Like you're using the same data, but you're using it very differently. That's how this works. And the last page is I found SAT problems about this stuff. They're actually a lot harder than what I'm doing right now, but it's using it. I'll try going over this when I get back from Thailand. But if you really want to know the answers to these problems, if you click on this link, this is where I got these questions, and it shows the answer key. So if you go to my blend, like where you go blended, like click on the link for this video, you can click on this link and it shows you how to do these 4 questions. And these were actually the 4 of the easier ones on that page. Like I skipped some weird ones I'm not even sure I could do. But yeah, that's try that out. But again, I don't expect you, if you don't know how to do these 4, that's okay, I guess. I mean, those are what the SATs care about. But you should be able to do what I put up here. Definitely. Okay, I hope that was helpful. I hope you're watching this while I'm in Thailand, and I'll come back when I come back from Thailand. I'll go over this again. All right, thank you. Bye.